Since the dawn of time, people have watched the night sky. Some people noticed that the heavens moved in a rhythm, and the rhythm appeared to influence events on Earth, such as the seasons and the tides. Some people claimed that the rhythm influenced life itself, and studying these influences could reveal the secrets of our past and our future. More importantly, others used a different approach, which developed into the science of astronomy. Wealthy rulers needed accurate calendars to predict the onset of the seasons, to plant crops and plan trips, and worship the gods properly. They were prepared to pay wise men to study the heavens and produce the accurate calendars they needed. Some 500 years before the Christian era, the ancient Greeks began to study the stars with fresh minds, freed from dogma, using simple logic and common sense. The mathematics needed for accurate scientific measurement of the heavens had also evolved in Greek culture by inspired thinkers like Pythagoras.
Plato, a great teacher, scholar of natural philosophy. What is the nature of the universe?
Pythagoras reasoned first and foremost in logic and in the primacy of mathematics. And so do I.
Mathematics? How is math so important?
Did you not read the statement above my door of this academy? Let no one unversed in geometry enter here. Mathematics is the basis of all measurements. The universe is eternal, alive, and perfect. A perfect globe.
What does the universe consist of, Plato?
I give to you the 4 elements of the Greek universe: earth, fire, air, and water. And they each have their form. Their forms are the cube, a solid object with 6 sides, the tetrahedron with 4 sides, the octahedron with 8 sides, and the icosahedron with 20 sides. To these I have added a 5th solid, the dodecahedron, with 12 sides. This is my model of the entire universe.
How did you come to this conclusion?
Well, as you know, I believe that the basis of all truth is the thought, the perfect thought. And so I observe that things have within them a perfect form as well as their real form. And these are all perfect shapes.
What is the center of the universe?
Well, I think it's self-evident that the Earth is at the center of the universe. Earth in Greek being geo, we can say that the universe is geocentric. Quite obviously, the moon, the sun, the 5 planets, and the outer stars all move around the Earth. I believe they do so in 8 perfect circles. The sun, the planets, and the stars have been created for defining and prescribing the numbers of time.
Oh, I see.
My question to you is this: what are the rules by which the movement of the stars can be accounted for?
How can we find out more?
Talk to my student Eudoxus. He has it all worked out.
Speaking as students of the Academy, we agree that Master Plato's thinking left us the magic of an idea. But it's an idea that crashes when you examine it.
Plato didn't explain why the planets seem to stand still at times, or even go backwards. Nor did he explain why they sometimes vary in brightness.
It might have been even better, with better measurements.
Yes, but after considering all the possibilities, I decided that there were not one, but several spheres for each planet.
To address these problems, we returned to our Pythagorean beginnings and devised a pure geometrical solution with 4 spheres for each planet. They all nestled inside each other, giving the planets they were attached to certain unique movements. Using this system of spheres within spheres, I could explain all the eccentric movements of the planets on paper.
But never their variations in brightness.
Still, it was a pretty good effort in theory.
But what keeps it moving?
Moves. I observe. This is my theory. What more do you want?
An explanation that works?
I have an explanation. I use 34 spheres. I believe that outside the 8 heavenly levels, there is a 9th one. I call this the prime mover, and, with a little help from God, this is what energizes movement in our universe. But this universe is finite and spherical.
How can it move around the Earth so perfectly and not fall down or whiz off into space?
Well, it's just logic that it must be held in space somehow, and since I can't see anything, it must be held in place around the Earth by something transparent or crystalline.
Aristotle speaks. It must be right.
Brilliant, yes, but far too complicated.
You do better.
Allow me. We can get a much better picture if the heavens and the stars are at rest while the Earth moves about the poles of the equator. We believe that the figures work out much better if the Earth and the planets rotate around the sun. The most important point I make to you is that you should take measurements. In fact, I have taken measurements of the distances between the Earth and the Moon and the Sun, and also their diameters.
What? Are you mad?
How come if the Earth whizzes around the sun, we don't feel a terrific wind?
That's right. How come the birds aren't swept away in flight?
How come if we jump, we don't land somewhere else?
How come, eh?
Get out of here, you fraud.
Who would dispute the great Aristotle? Of course the Earth is at the center. You see, we've almost perfected this geocentric model. Hipparchus of Rhodes developed a wonderful catalogue of the stars. Apollonius of Perga developed a model that improves on Aristotle's a bit using epicycles. Thus, I have gathered together all their work and completed my tables for calculating planetary motions. These can be used by ships navigating at sea, or by farmers and rulers seeking a better calendar.
My newly developed model explains the odd movements of the planets by discarding the idea of spheres and replacing them with the idea of little wheels called epicycles. These are attached to the edge of big wheels, which I call deferents, which revolve around the Earth. In some cases, epicycles are placed on epicycles. This may look highly complex, but it explains why some planets appear to be moving backwards at times and why their light appears to be dimmer, then brighter. The centers of the epicycles move in circles as they go around the deferents at uniform speed. And at the same time, the epicycles to which the planets are attached move in their own uniform circles.
It's very complicated.
Don't you see? It's so complicated, it must be right.
Yes, anything so difficult to understand must be right.
Now, I know my model requires 40 wheels moving the sun, the moon, the 5 planets, and the fixed stars through the sky, but you must admit it's beautifully cobbled together. I'm going to publish my measurements, records, and observations in a book I'm calling Almagest.
Almagest?
It means the greatest. I predict it will be the last word on the subject forever. Or at least 1,000 years.
So that's how it ends for the Greeks. It's a much more complex model than my original simple little thing. All those wheels and wobbles. And it never could predict accurately where all the planets would be all the time. And in time, we might eventually have realized that it was wrong. But before that happened, the Dark Ages began. And all over the Western world, the lights of learning began to blink out, one by one.
The problem is that a wrong idea is still wrong no matter who says otherwise.
But it is the church orthodoxy. Thomas Aquinas said so.
We're now in the 16th century, and the model still can't predict where the planets are going to be. And therefore, our calendars are still wrong. Let it crash, I say. Let's make a fresh start.
That's heresy.
Shh. Actually, I really got involved by trying to remove some of the problems with Ptolemy's model. But the more I studied it, the more I realized that it had a fatal flaw.
Like what?
Well, I realized that the geocentric model is too complex to be true. So I searched for a simpler way, and I found Aristarchus. And I decided to completely alter our frame of reference by placing the sun at the center of the universe once again.
That is so against the church, Nicholas.
But you know, suddenly I realized it works better this way. If you put the sun in the middle, it explains why Mercury and Venus are always near the sun. It's because they revolve in perfect circles around it. That also explains why they sometimes look brighter to us. Because we are also revolving around the sun, and sometimes we're close to those other planets, and sometimes we're not.
No, it can't be.
Ah, yes. And it also explains the retrograde motion of Mars. If we accept this heliocentric model of the universe, I can work out a link between the planets and their years, and the distances between them, and finally, I can predict exactly where any planet will be at any time. This, of course, leads to accurate calendars.
They'll laugh you off the stage of scholarship.
Of course, all this goes against the teachings of the church as well.
As a doctor and a church canon, you cannot risk scandal, but, well, what will you do?
Don't worry. I'll only publish my findings on my deathbed, in my book, On the Revolution of the Heavenly Bodies. And it is for this work that I am regarded as the father of modern astronomy.
Contrary to popular belief, we didn't ban it after he died. In fact, Pope Clement VII encouraged him to write the book. And after all, it was dedicated to the previous Pope, Paul III.
"30 years after Copernicus, I came into possession of his book. As a real and professional astronomer to kings and emperors, I found it interesting, just as alchemy and astronomy are interesting, and indeed mathematics and women are interesting, if you can avoid fighting over them. Anyway, with a little financial help from the King of Denmark, I set up this observatory, equipped with exceptionally large and accurate instruments. I began to make and record the most meticulous astronomical observations. For 20 years, I recorded my observations, keeping everything I learned to myself. For 20 years, I labored in Denmark, and then at the court of the Holy Roman Emperor in Prague. I made the most careful and accurate astronomical observations ever.
These are remarkable figures, Tycho. I am most impressed.
I took accurate planetary observation to new heights, using the best instruments, making exhaustive and remarkably accurate measurements. Enough looking, son.
So, sir, do you now have a theory that works?
No. No, I still can't make the figures prove my theory of the heavens?
Yes. What exactly is your theory?
It's sort of a cross between Aristotle and Copernicus. A concept where the planets revolve around the sun, but the sun revolves around the Earth. Stationary and stable at the center of the universe.
Excuse me?
Oh, yes. It may seem very odd to you. But like Copernicus, I too am a Catholic. The Church is violently opposed to any heretical ideas, especially now with the Protestants and all that. My theory is a safe path between heresy and heliocentricity. It is a theory many other astronomers accept.
Perhaps you need a mathematician to sort through all this.
Oh, yes. But I need someone who's safe. Someone who'll do as he's told.
Oh. Well, I would. And I'm a pretty good mathematician.
Ah, yes, of course. Kepler. Well, get on with it then.
Oh. May I see more of your work now?
You may see what I let you see. Here are my observations from Mars. I want you to check and cross-check these calculations for the planet Mars. And don't touch anything else.
Now, I see that we differ in many ways.
Less chatting, if you please. More work.
He's a suspicious man. In fact, he's downright crazy. He took accurate measurements in order to be a better astrologer. These measurements he made have nothing to do with what most people would use to measure the stars. I had to fix things up before I even started doing the maths.
Less chatting, Kepler!
Oh dear. The sad news of his death in 1601 was brightened by the unrestricted access it gave me to his figures, his papers, and his marvelous equipment. It was only for a short time, however, because Tycho's family swept in one day and took everything away. None of it was ever seen again. Luckily, my own work was largely completed before that happened. I noted that they each travel their orbit at different speeds, although their speed may vary as the planet's orbit carried them closer to the sun. They couldn't be circular orbits. With the help of these observations, I worked out that Mars's orbit was very elliptical. With more calculations, I noted that all the planets had elliptical orbits. Then finally, I found a relationship between a planet's year and its distance from the sun. We could at last predict where a planet would be and thus get our calendars right. Thanks in part to Tycho's work, I formulated my 3 laws of planetary motion. Theoretical astronomy, as opposed to empirical or observational astronomy, had come of age.
My telescopes allowed me to make the most amazing celestial observations and discover things like the moons of Jupiter. Now, the moons of Jupiter showed that not everything revolves around the Earth. Of course, my colleagues just laughed.
The fact that you found some moons orbiting Jupiter may prove Aristotle and the Greeks wrong, but it does not prove Copernicus right. The Church supports your scholarship, Galileo, but you must present a balanced argument.
I formulated my great theory of inertia by showing that a pendulum will go on swinging forever unless something acts to stop it. And so too, the planets should go on forever. I wrote 2 books about it, in Italian, for the common man to read.
Galileo Galilei, you may discuss the Copernican theory as a hypothesis, but without proof. You cannot teach it as a fact.
But it's the best theory by far.
That's not the point. You have many enemies in academia, and they will bring you down with theology, not science.
But how can I recant an obvious truth?
You have no evidence.
The tides, they're proof.
Don't force our hand, Galileo. You ascribe the geocentric model to the simpleton?
Oh, the geocentric model is a stupid argument after all. I mean, the Pope's a moron to ascribe such an argument as dogma.
How dare you insult the Church after all the support we've given you? It's the Inquisition for you, you rascal!
Galileo died in 1642, the year I was born. Kepler had died 10 years earlier. Both men left me with a puzzle to solve. Kepler with his laws of the motion of heavenly bodies, Galileo with his laws of the motion of bodies here on Earth. My role was to iron out the differences between these two lines of thought and bring them together by demonstrating that the laws of motion on Earth and the laws of motion in the heavens are one and the same. And I did it by studying our own moon. Here, we see the moon orbiting the Earth. Here, I have my own moon. If we spin a stone on a string, we see two forces in action. One, the inertia of the stone at a tangent, wants to fly the stone off into space. The other, gravity, here represented by this string, stops the stone flying off. Here we see two interacting forces. When I calculated the force of the Earth's attraction on the moon and combined this with the moon's own centripetal force, I got a result that matched the moon's observed motions. What's more, my calculations worked for all heavenly bodies. And that led me to my universal law of gravitation. Thus, I completed a synthesis of astronomy and physics which did away with the old models and theories by conclusively providing the reason why the universe works like it does. In a way, I found that simple, perfect formula that Plato and all those who followed him had searched for. I showed how the planets and stars all follow the same simple, perfect set of laws. When I published my Principia in 1687, the study of the heavens ended its long climb towards the light of reason. And when my work was publicly acclaimed by the Royal Society, I like to think that Plato smiled.